Hello and welcome to What the Math. In today's Universe Sandbox 2 video, we're going to be playing around with our home planet Earth, and specifically, we're going to be placing it at different distances from the sun, and just to see the effect and to basically discover what we call a Goldilocks region around our sun. This is the region where, let me just find my sun, where's my solar system, where you basically have just a perfect temperature, not too hot, not too cold for life. Now, before we find that region, let's place a bunch of Earths, and I'm going to start placing maybe 4 or 5 different versions of Earth. One is going to be right next to the sun, right here. One is going to be a little bit in the distance, maybe over here, and one over here, and I'll just say one somewhere over there, and then maybe one more just over there. Alright, that's good. I'm going to run the time a little bit just so that they can heat up and cool down. Because usually Earth in this game starts at 15 degrees Celsius. Alright, so let's just run this for a few days, and then we're going to explore and see what happened to our beautiful home planet, starting with the one right next to it. Where is it? There it is. Okay, let's zoom in on this. Oh my god, look at that. Look at this beautiful orangey yellow, beautiful looking thing of a ball. Alright, the temperature here is 3,300 degrees Celsius. And it's surprisingly, not surprisingly hot. I'm not sure if we expected anything different from this, but basically, if you're right next to the sun, this close, so close that it really hurts your eyes to look at it, this is what you get. And if you wanted to see what the sun would look like from the planet, from our home planet, if you're actually standing on top of this, well, here you go. This is the surface, and this is what the sun would look like from our planet. And it's just ridiculously hot. I'm going to decrease the time just so you can see this in real speed, in real-time speed. Here you go, almost 1 second per second. So this is what it will look like. This would be your everyday life if you could actually survive on this molten, beautiful planet. And the sun would pretty much take most of the space in the sky. Alright, so obviously this is too hot. This is even hotter and closer than Mercury is. Alright, Earth number 2 is right here. It's a little bit warmer, and when I say warmer, I mean it's really, really hot. But it's orangey, and there's some hard surface on it. There's basically these continents floating around. There are kind of really, really hot pieces of rock, and the sun would look something like this. It would be a little bit smaller, but still pretty big. And the temperature here is 1300 degrees Celsius. And you can't really, there's no features here that you can't really tell anything apart. Obviously, the darker side is a little bit cooler than the brighter side, but not by much. And the clouds that you see flying away from the sun, that's basically the reason the comets have the tail as well. It's basically the various particles that are being stripped away by the solar winds, and they're taken away into the space. Alright, so that's Earth number 2. Earth number 3, and look at that. Look at this beauty. 600 degrees Celsius. But look at what you can actually see on it. You can see almost every continent. So essentially, the only thing it's missing, and there's some lava right here, I think. The only thing that it's missing is water. There's no water here because it's too hot for water to form. So it's basically just accelerate time, so you can see various continents here. Ooh, there's some slowing down going on here. I think I might have increased effects in this video game a little bit too much. This is actually the new version 13.1 that does include some awesome new effects, and I'm gonna show them to you once we're finished with this. But yeah, it looks a lot more beautiful than before. If you look at the space around you, it's actually a lot more detailed. But yeah, so this is South America, and look at that. There's a trench here. You can basically see almost every feature that would usually be ocean, but you can actually see this in the game. If you keep going, there's going to be the Pacific Ocean, or what is left of the Pacific Ocean, which is now basically a big Pacific lava ocean place. There's some lava in there. And if you look at the dark side, you can even see parts of lava on the dark side because it's so hot that it creates these pools of lava. Anyway, so here's Australia. You can see there's a relatively shallow area right here, and this is the Pacific Ocean with the Mariana Trench somewhere over here, I believe. I think that's it. Or possibly no. I can't even tell. Is that it? No, that's the Japanese Trench. Where's the Mariana Trench? I don't even know. And basically you can see all the ridges and everything. So this is pretty awesome. So you can see the continents and the ocean floor. And what it would look like from this planet, from this beautiful gray planet, well, this is what it would look like if you looked at the sun. It would be just a little bit larger than what we see. Alright, and moving on to number 4. And number 4 is 131 degrees Celsius. Now, surprisingly, it does still have water in it. I think this might be a calculation mistake, or possibly because this is the average temperature, because it shouldn't really have water anymore. Water does evaporate at 100 degrees Celsius on average, and this should be all clouds. But you know, this is still a earthy looking planet, and the sun from this planet would obviously look a little bit smaller. Almost the same as what we would see it, but yeah, this looks almost no different from what we see, except that there's a little bit more evaporation going on because of the solar flares. And Earth number 5 is essentially our normal Earth. So this is what we live on, maybe a little bit farther away from the sun. And you can see there's this is actually what the other Earth was missing. It's the snow caps. There were no snow caps, and because there were no snow caps, it would technically have to have more ocean. Unfortunately, this game doesn't emulate this well yet. Possibly in the future, but yeah. So this is basically a normal Earth, and the sun from this planet would look like this. Oh boy, this is actually a little bit smaller than I thought it would be. Anyway, moving on. Because I think this is actually a little bit farther away from the sun than our actual Earth. Now, let's go to the next one. Let's go to the farther distances. And I think this is it the last one? Yeah, possibly this is the last one. And here, as you can imagine, the temperature is a little bit cooler. And there's a lot more snow going on. So if you look at it, this is 11 degrees Celsius. And there's already a lot more snow. There's basically almost the entire North America, at least the western coast, is covered in snow. There's snow in South America. There's snow almost everywhere, basically. The caps have grown in size. And interestingly, the albedo effect, if you look at it, where's the albedo? Albedo effect has also increased, making the planet a little bit more reflective, which actually would then decrease the temperature a bit further. So basically, if you're reflecting more light from the surface of the planet, the warming effect will be lower and the cooling effect will be higher, making the planet get cooler and cooler. So the more albedo you get, the cooler you get. So as this increases, the temperature will decrease. I don't know if you can see it, but it's actually going to start decreasing. And obviously, albedo effect is highest in the snow because snow is white. It reflects almost every sunlight that comes to it. So that will create the highest possible albedo effect, making the Earth basically very, very, very cold. Now I'm going to place one more Earth. I actually should have placed a little bit more. I'm going to place one more Earth. Let's just say double the distance from where this Earth is. So this is the sun here. And this is the new Earth that's going to be right there, and maybe one more just in case that doesn't work, because I'm actually looking for something really specific, and what I'm looking for is kind of this, I think. This is basically Snow Age. This is what we today think Snow Age would look like, where basically almost everything was at least on the surface was covered in ice, and there was actually a lot of sea ice as well. Let me see if this is a good simulation of that. Yeah, there's a lot of sea ice right here as well, which basically connects North America and Europe, which is how we think people were able to walk all the way from Africa, where our species was born, to Asia, to then North America, and this is basically how a lot of the ancestors of the North American and South American natives managed to make it all the way there from all the way here, which is I believe this part here called Cape of Africa. Is that what it's called? The Horn of Africa. What am I talking about? Horn of Africa is essentially where we think human species started about 100,000 years ago ish. So they kind of managed to walk all the way here, and probably this way, and then through Asia, and essentially they made it all the way to North America by walking on ice during Snow Age, Ice Age, using the ice caps right here, and then made it to North America and then South America from there as well. So basically that's Ice Age. That's what approximately it looked like when it happened, and we kind of think that there were actually more than one. There might have been at least 5 different ice ages, where it sort of looked like this. It sort of, the Earth sort of looked like this. It was probably much colder than it is today, and then somehow warmed up. We don't know how exactly, there's lots of theories, but yeah. Anyway, so let's look at the extreme example of Ice Age, something that we would refer to as the... Oh, okay, that's not, it didn't actually create what I was looking for just yet, but it's getting there. So this is a really dark Earth. If you try to find the sun, it's probably going to be very difficult, but it's somewhere right there. This is what it would look like from like Pluto. And basically what I'm trying to create here, and it's still cooling down actually, we're trying to create a snowball Earth. And there's actually a theory that several million years ago, like millions of years ago, I guess something like over 100 million years ago, there was something called snowball Earth. At some point, Earth was entirely covered by snow and ice. It was completely white. The albedo, if you look at it, it's already 46, and it was actually much higher than that. And basically, it was totally covered in ice. And people are, or not people, but scientists think that when that happened, there must have been some kind of a catastrophic event that caused the Earth to basically to warm up suddenly, because it wouldn't make sense that it would actually stay as a snowball if there was nothing catastrophic to make it warm up like that. It's really funny how there's still lights in there. It's like as if people actually survived on this planet, which is actually possible. If this ever happens, I'm sure we'll have technology to make this happen. But yeah, the lights that you see is basically the actual lights that were taken from the International Space Station. It's basically what it would look like from space if you were to fly over Earth at night. Okay, so let's just wait for the snowball to actually happen, and then I'll show you what I mean. And here you go, this is what I was looking for. This is the snowball Earth. Basically, minus 31 degrees Celsius is when it's completely covered by ice, even though there's still some lights there, but it's imaginary, it's not real. Anyway, so you can kind of make out the continents there actually. There's shapes of continents that you kind of can make out from below the ice. But this is what some scientists think happened to our planet many hundreds of millions of years ago. And it's strange, because if that happened, the albedo effect would be really high, so it would never be able to warm up. No matter where it was around the sun, unless it's super close to the sun, it would not be able to warm up. So even if I were to place this planet really close to the sun right now, I'm just going to do this right now because I do have a copy of this planet a little bit farther away. Let's actually, just for fun, place this. There it is. There's another snowball here, snowball Earth right here. Let's place it really close to the sun and see what happens. And when I say close to the sun, I mean about half the distance from where Earth is. So it's right now at a distance of approximately 0.5 astronomical units, which is about 75 million kilometers. And still white. Still white. It's going to warm up really slowly, but it's still white. And even here, it would take a really long time for it to warm up. So there would have to be some kind of a catastrophic event to basically occur for this to suddenly warm up. And people think it was probably either volcanic eruption, a massive volcanic eruption that suddenly released all these gases and fire and temperature and heat, or possibly, yes, you guessed it, a meteorite. So that's what we're going to do. We're going to launch a meteorite or a comet or something. What is this thing here? There's actually a new bar on the bottom that allows you to quickly launch objects at things, which is something that I really love doing, and I think everyone loves doing that. So we have a choice of a small satellite or an even smaller satellite. I believe this is a satellite of Mars. Deimos is the Mars satellite, and there's a slightly bigger one here. So let's do it. Let's actually launch a thingy at the thingy and see what happens. So I'm gonna slow down time a little bit and launch it maybe right here. Oh, I can't even see it. Where is it? Oh, it's so tiny. Too tiny. Can we see it from here? I don't think so. All right, that was a little bit too small. I don't think that's gonna do anything. That will do no damage at all. All right, that was a disappointment. I think it's still flying. I just can't see it. Okay, let's launch something bigger. Let's launch Mimas. Mimas. Oh, here we go. Oh, no, too slow, too fast. I mean, too fast. let's actually take a look at this before we continue. So let's look at what it looks like from the planet. If you have this huge object approaching your planet, and where is it? Where are you, Mimas? There it is. Alright, so it's still quite far, so we can actually take a look at what it looks like on Mimas if you're approaching Earth. Let's actually zoom in on it and see what it actually looks like from its surface as it approaches Earth. It's gonna be really dark though because we're on the dark side. So wait, let's look at Earth, and okay, and this is what it would look like as you were to approach the planet. Okay, so it's slowly approaching Earth, and basically this is what the view would be like from this object approaching our planet. Now this is not as much fun as I thought it would be. Let's actually do an observation from the actual Earth, because I think it's a little bit more fun to see this object approaching from the planet and then crashing on top of us. So I'm gonna accelerate time just a little bit. This is what would happen when the object would crash. As you can see, it's instant heat up, instant melting of ice. There's huge explosions, incredible power that's being released, and this is actually going to really heat up our planet. And this was a relatively large object, but not super big. So if I accelerate time right now, you'll see what happens. I'm going to do this again from the actual perspective of our planet, with another object, but just to see what this would look like when it actually crashes and starts melting everything. So I think our planet actually starts increasing temperature. Or maybe not, actually the temperature is stuck. Anyway, I think it might be not really well simulated in this game, but we do have this huge fiery area and ice around it completely melted. So this would obviously decrease albedo and will most likely cause the huge melting of ice around the planet. Oh no, look at that, it's actually decreasing a little bit. And there's more things crashing on our planet from the other side. These are the remnants of, what was that planet called? Minimus? I forgot. Anyway, so these are leftover pieces that were actually released from the crash, and then they land on the other side of the planet. So now we have this huge release of various gases, various heat that will actually warm up the planet. Now in this game it's kind of hard to simulate this, so basically it is simulated it a little bit, but not to the effect I was looking for. But what I wanted to see is, let's actually crash something much bigger, something like Mars. And we're going to use this other Earth that I have somewhere over here. And what we're going to do is observe what it looks like from the surface. Because that's what I was actually trying to do, just I kind of failed at it. Or better even, here's the moon. Let's actually crash the moon, because that makes more sense. The moon is closer. Okay, here comes the moon, and we're going to be observing it from, let's just say, here. That makes sense. And there we go. So this is a situation where the moon decided to no longer orbit around our planet and kind of crash on top of us. And it would make no sense, obviously, but you never know. And as it approaches our planet, increasing in size and basically taking away more space in the atmosphere, you get to even you can even see some of the features on the moon, which is pretty awesome. But yeah, so this is what it would look like if the moon literally just crashed on top of us. And there you go, sudden heat up of everything starts melting, huge earthquakes, huge explosions, or large explosions. I mean, this would obviously not look exactly like this, but the actual approach would be very similar. And then we have fragments flying out of the moon, which are basically then going to crash on the other side of the planet. Everything around the planet starts heating up, warming up. The entire ice bowl is melting and turning into a very hot object. And this may have happened approximately 4 billion years ago, when an object crashed into our planet. And then as our planet started spinning around, it released a piece, or basically a bunch of fragments that then materialized into our moon. So actually the moon was born in a similar fashion by an object crashing into the early Earth and then essentially being released from the spinning Earth thingamajig. But look at how beautiful this is. I really like the new effects that they've added. This is amazingly gorgeous. So yeah, on one side we have something that used to be icy but no longer icy, is actually warming up really fast. It's currently at 750 degrees Celsius. And on this side we have this molten, beautiful creation that was basically the reason or the cause of the moon crashing into it. And there's still the shock wave that's moving across the planet. It's actually pretty awesome. Look at that. There's a shock wave going across it that's basically heating up the planet as it goes through it. So I'm just going to accelerate this just to see what happens afterwards. And that's really it. So I think the idea behind this video was just to explore different effects that were added in this new version, and also just to see how Earth would change depending on where it would orbit around the sun. Now it's important to understand that there is really just one region around the sun, or a very specific region around the sun, where it's possible to have just the right temperature for liquid water and life sustainability. And this is what we call a Goldilocks region, or Goldilocks region of solar system. Every sun has it, and it's actually possible to see it in this game. Oh wow, this is so bright now. It's at 3,000 degrees Celsius. Whoa, that is extreme. It's actually just as bright as the sun almost. And it's still warming up. It's not actually even finished yet. It would probably even have its own Goldilocks region now. Actually, I'm kind of curious. Let's see if it actually does have a Goldilocks region around it. And to see that, you need to click on View. And then in Simulations, if you go down somewhere over here, it's going to say, or actually it's not in Simulations, it's in View. You have to click on Habitable Zones, and then basically if you click Flat, okay, well obviously Earth has nothing, but if you look at the sun, if you zoom in, you'll see the red region is basically where it's too hot, blue region is where it's too cold, and the green region is where the planet should be for a sustainable life. And this is the Goldilocks region of our sun, or any star really. All the stars in this game have this, and some stars have it very tiny because they're either too hot or too cold or too small, and some stars have it really large. So you can play around with these features and see if you can create a completely new solar system just based on the Goldilocks region, and put all your planets there so that they're all habitable. Anyway, so this Earth is ridiculously hot and it's still warming up. So this is what would happen if our moon suddenly crashed and decided to no longer be in orbit around us. So our Earth has also increased in mass because now it has Earth plus moon in it. And so it's a little bit larger, it's a little bit, but a little bit less dense because our moon is not as dense as Earth. And this is basically Earth at 4,000 degrees Celsius, and it's still increasing in temperature. So it went from minus 40 degrees Celsius to 4,040 degrees Celsius. And it's finally done and warming up at 4,727 degrees Celsius. And this is what it would look like. Completely molten and beautiful. Almost to the temperature of the sun, actually. Alright, so Earth has become sun. This is how you do it, by crashing moon into it. Cool. Alright. And I think that's it for this video. I'm going to pause this here, and this was basically me exploring Earths around the sun. Thank you for watching, please subscribe, and game you later, alligators. Bye bye.